This is the spec for the module on probability. Probability. And we really just want to, we could call it probability 1. And we really just want to test students' abilities to do kind of basic counting probability, to understand the probability of an event is the number of ways that event can occur over all of the possible events. So one example problem would be if, or you flip a coin 3 times. And I think we'll always want to do it 3 because we don't want the students to have to do the math just yet. I want them to actually look at all of the different combinations of flipping coins, or all of the permutations, and then actually figure out the ones that meet this condition. So you flip a coin, you flip a fair coin. Let me write that. You flip a fair coin. You flip a fair coin 3 times. What is the probability? And here we can have a bunch of different conditions. It could be the probability of getting more than 2 heads, or less than 1 tail, or all tails, or all heads. And that kind of the random number generator you can think of the different statements. But what is the probability of getting at least 2 heads? And when the student clicks hint, the first hint will show all of the combinations. Here are all of the possible flips, or all of the possible flips of the coin. And then we could write them down, and it would be maybe nice to color code them. So you have heads, heads, heads. You have heads, heads, tails. You have heads, tails, heads. And then you have, and it just keeps going. Let me just finish this up. We're going to have 8 of these. And then you have, I'll just write in one color right now just for brevity, but I think you get the idea. You have heads, tails, tails. You have tails, heads, heads. Then you have tails, heads, tails. And you have tails, tails, heads. Then you have tails, tails, tails. So this is the first hint that students get. And then the next hint is, you say, let's see, how many? At least 2 heads. At least 2 heads. So 1, 2, 3, 4. 1, 2, 3, 4. So 4 of these possible scenarios meet our conditions. And actually, this should be written in black, not purple, but I think you get the idea. Meet our conditions of, that's going to be the same conditions here, at least 2 heads. And so we could redraw this. Let me copy it. Let me paste it. So we'll redraw that right there. But in this hint, we'll actually highlight the four that meet that constraint. So we would have it at least 2 heads. At least 2 heads. Oh, at least 2 heads. So we have this one right here. And we could underline them maybe, or box them, or however we want, or we can even star them maybe. 1, 2, 3, and then 4. And then, so we can, then the last hint will be, so here are all of the, actually this first hint should be, here are all of the 8 possible flips of the coin. 4 of these 8 possible scenarios meet our conditions for at least 2 heads. So the probability is 4 out of 8, or 1/2. And of course, the choices could be 1/2, 1/4, 1/8, 3/8, just a bunch of different things you could put here. 2/3. That's one type of question we would want in this probability. And you can think of all of the different types of things you could say: at least 2 heads, at least 2 tails, all 3 heads, no tails, at least 1 head. All of those are the different types of probabilities, but we want students to have to count it out. Now, the other type of problem we want to see here, once again, this is probability 1, is you pick a number at random from this set, and we'll give them a set of numbers, not too many numbers, maybe 5 to maybe 12 numbers, and we'll just, it could be 2, 5, 6, 9, 11, 12, 13. And then we could say, what is the probability of selecting an even number, or an odd number, or a prime number, or a number divisible by 3 if you want. But we don't have to get too fancy. So you say, what is the probability of selecting a number, or let me just say, a prime number. A prime number. And then the first hint, we could say, well, what are the prime numbers? 1, 2, 2, 5, 1, 2, 3, 4. 4 of these 1, 2, 3, 4, 5, 6, 7. 7 numbers are prime. And then we could list them. 2, and actually the best thing would be to have the same list here, because I really want them to understand that we're counting how many satisfy out of all of the possible scenarios. So let me copy this and then let me paste this. Our prime, and then we could circle them or just highlight them in a different color, whatever is easiest. So the 2, the 5, the 11, and the 13. And then we'd write, so the probability is 4 out of 7. And of course, you would put the appropriate choices. You put 4/7 there, 1/2, 3/7, all the different probabilities there. Now, the last type of problem I want to do on this, and this is they're all kind of similar in idea, but kind of approaching the problem from different ways, is to draw a diagram where you have a circle. You have maybe a circle like that, and then you have a smaller circle someplace over there. Something like that. And you could color them however you like. And then if you say a random point, or let me write it this way. So we'll give some information, enough information to figure out the areas of these two circles. The area of the larger circle is x, or we could just give them the radius, actually. The radius of the larger circle is x. Maybe we could say the diameter of the smaller, just anything that allows you to figure out the area. Smaller circle is y. We'd actually give them numbers here. So maybe that's, 5 inches. And maybe this is, it doesn't have to be inches. Maybe this is 1 inch. And then you say, you select a point at random. A point is selected at random from the larger circle. What's the probability that you selected a point from the smaller circle? What is the probability that the point lies in the smaller circle? And over here, the hints are, the first step, actually I'm going to continue this in a part 2 of this video. I don't want to rush it, and already my writing is very messy. I'm going to continue this in part 2 of this spec.